Discuss about the Poisson distribution. What is exactly a Poisson distribution? Poisson distribution is a discrete probability distribution that is created to overcome from the limitations of the binomial distribution. What are exactly the limitations of the binomial distribution? We have already discussed a problem in which we toss 3 coins simultaneously and we have to find getting exactly 2 heads out of that, and we got our answer as a 3/8. Just think of it. Now we have to toss 100 coins simultaneously and we have to find getting exactly 2 heads. This become too complex because just think of it, p raised to 100, and we have to calculate those all the things. It become very complicated. For such purposes, the Poisson distribution is introduced. Here we have single variable x that represent the number of occurrence, and we have the lambda. Okay, I'm going to discuss about whatever used in that probability mass function in the next presentation. Okay, here we have the probability mass function. Probability mass function can be represented as e raised to minus lambda into lambda raised to x divided by x factorial. Here, as you know, e is the Euler's number that is represented with the 2.718, and x is number of occurrence, means after some interval the event is gonna happen again, and x factorial, as you know, factorial of x. Lambda is equal to expected value of x when that is equal to variance. Discussing the variance, we need to know about some of the concepts like the mean. Mean can be represented as sum of all the data that are present in a data set to the total number of data. Or example, I will just take a data like 1, 2, 3, 4, 5. Totally we have 5 data, and what is the sum of these 5 data? 1 plus 2 become 3, 3 plus 3 6, 6 plus 4 become 10, and 10 plus 5 become 15. 15 by 5 it becomes 3, and mean and average are almost same, and the mean of this particular data set is 3. This is how we calculate the mean. And now it's time for median. Median is the middle value of the data sets. For example, here we have 1, 2, 3, 4, 5, and what is the middle number of these data sets? It's 3, and 3 is termed as a median. And what is mode? Mode is the highest number of all the frequencies of the given data set. For example, we have 1, and we have 2 times, and we have 3 times, and we have 4 1 time. And here 1 is repeated 1 time, 2 is repeated twice, 3 is repeated thrice, and 4 is repeated once. And here 3 is repeated thrice, means the mode of this particular given data set, it would be 3. As you know, the frequency of 3 is 3 times, and this is the highest in the given data set, and this is what we call as mode. And here, when we are talking about the variance, here we go with the variance. Here we are given with some of the data set, and average value of these all the data set, or mean value of these all the data set, is become 3.33, and we will round off this particular thing to 3, and just start calculating the farthest value of farthest value from the 3. Here we have the 3, the farthest value will be 1, or it will be 6. 3 minus 1, it will be 2. 3 minus 6, it will be almost around 3 itself. Means the farthest value from the average will be 6, and the difference will be 3. Thus, variance of this particular data set would be 3. Now coming back to the presentation. Here, the lambda is equal to expected value of x when that is equal to its variance. As we know, variance will remain as it is when it is very closer to middle value. Here we have the value 3, and 3 is equal to 3. Thus, the lambda value become 3 because the variance value as well as the average value become same. Thus, this is what represents the lambda value. Lambda value is always given whenever we are dealing with a Poisson distribution. Here we have the different lambda value and the distribution. Here we have lambda value equal to 0.5, therefore the curve goes like this. And next we have 1, therefore curve goes like this. 2, it take a highest value and it will come back. And in the 3, it will gradually take the highest point, it will come back. And 4, it will submerge, for the 6th it will submerge, but it will take up the value, and this is the lambda value. And where exactly the Poisson distribution is used? As we already discussed, if you have very large n value, then it will be used, but it has a separate application. It is used in the nuclear physics. As you know, we have the two elements in the nature. One is a radioactive element and one is a normal element. The radioactive elements like uranium, plutonium, and the thorium, these all the elements radiate themselves, and at last they eventually disintegrate and disappear, as they won't survive in normal nature. Therefore, we have to find out at what rate they are disappearing, and the Poisson distribution well suits for this particular problem. Here we are given with a problem. Let's consider a sample of a radioactive substance with an average decay rate of 2.3 per second, and we want to calculate the probability of observing exactly 3 delays in 2 seconds, 2-second interval using the Poisson distribution. Here we are given with the formula. Let's go with the solution. Here we have the lambda value. As you know, we have 2.3 as a delay rate per second, means per second we have 2.3 as a delay rate, and we have to find it for 2, right? We have to find it for 2 times, therefore for 2 seconds, therefore it would be 2.3 to 2, that will be 4.6, and e raised to minus 4.6 into 4.6 raised to 3 is the value that we need to find after, means what would be the probability that the mass will be 3 delays after this particular event of 2 seconds. Thus it would be 0.163. Therefore we can say that there is a 16% chance that we can get mass of 3 delays after 2 seconds, because it would be around 4.3. therefore there is very less chance that you can get the value, and this is how we go with the Poisson distribution. And when we are dealing with the Poisson distribution in the NUMPY or the machine learning, we have the separate form code to deal with it, and in the sci-fi we are given with exact probability mass function, but in the NUMPY we deal with it differently. We have the code as NUMPY or INP dot random dot Poisson 2,100. It's gonna give us some intervals, and if we equate it to the given number x, then we gonna get our value, and this is how we deal with the Poisson distribution. Here I am going to import the NUMPY SNP. As I already discussed, we have the average decay rate as 2.3 milligrams per second, and we have the time interval as 2, and the number of event as 3, and we're gonna consider the np.random.poisson, and we have to mention the average decay into the time interval. For example, means we have to find for 2 seconds per second, it's gonna decay 2.3 grams, like milligrams, right? Therefore I'm going to multiply 2.3 to 2. I'm going to get an answer as a 4.6, and we have answer as a 4.6, and we get some Poisson distribution, and we have to find those all the probabilities whose value is equivalent to 3, because we are finding it with respect to 3, and we're gonna get some answer, and we have to find the mean of that particular answer to get the probability. As you know, here we have our answer that is equivalent to 0.16, that is 16%, and this is how we go with the Poisson's distribution. Well, do subscribe our channel for regular updates. Thank you.